Okay, I'm starting the module number 4, that is phase diagram. In this module, you need to know about some physical chemistry like things. Okay, now what is phase diagram? For that, first you have to get some knowledge about phase. Okay, I'm starting the presentation. Okay. Can you see the presentation? Please reply anyone. Now can you see the presentation? Can you see the note? Okay. Okay. If sound is not clear, I will send the lecture. Okay. Don't be worried. I'll send the lecture along with the notes. First of all, you have to get some knowledge about phase. Now, what is phase? Phase is nothing but the homogeneous portion of a system. System means system is nothing but some specific material or some portion of specific material. Okay, from this there is a definition of system. System is nothing but some specific body or specific portion of some material, and if a system is homogeneous, then the total system is considered as the phase. In the definition also you may see that every that is written as every pure material is considered to be a phase. Phase means nothing but if some portion of a material is considered for some test or for some other operation, obviously that portion of material is considered as phase. Phase is nothing but in case of this type of physical chemistry part, the phase is nothing but some specific homogeneous portion or part of some material or some system. Okay, now for an example, you may take an example of a simple example like sugar water syrup. Okay, in sugar water syrup, you may take that sugar water syrup like a single phase, because in a sugar water syrup, sugar is in a dissolved condition, and obviously the syrup or the mixture is homogeneous, and that sugar water syrup will be considered as a phase. But if you want to know about not single phase but multi-phase system, you may take also the same example of sugar water syrup. In that mixture, if you continue to add sugar to the syrup, then obviously after some time when the mixture or the solution is uh, uh, full of sugar, that means saturated system, after that the sugar will not be dissolved in the syrup, then obviously some portion of solid syrup sorry, solid sugar will remain in the solution. In that case, in that after saturated system of sugar water syrup, then there will be two different phases. One is sugar water syrup, that is liquid phase, and one is solid sugar, that is solid phase. Obviously in the previous semesters, maybe fourth semester, you have studied in soil mechanics, there will be three phases in a soil system in general case, and obviously in dry soil there you have studied that there are two phases. Those are also phases, and same as those cases, those soil cases, in this subject also the phase is same, that is homogeneous portions are considered as phases. Okay, now coming to the next part, that is component. Component is nothing but the compounds or the material by which the alloy or the mixture, yes, the alloy or the mixture is composed of. Components are nothing but the two or more compounds or material, like as an example you may take the example of brass, in which the components are copper and zinc. Okay, and previously I have discussed about system. System is nothing but one specific part or specific portion of any object or any material that may be of alloy system, or that may be of some specific metal system also. Okay, and that is called system. Now in the next part there is one important parameter, that is solubility limit. Yes, there is an important parameter, that is solubility limit. Now in the previous class we have discussed about solute and solvent. What is solute and what is solvent? Solvent is nothing but the greater part of a solution, and obviously solute is the lesser part of a solution, and solvent is the greater part of a solution. Now in a sugar water syrup, obviously water is the solvent and sugar is the solute. Solubility limit is nothing but the limit up to which a solute can dissolve in a solution. Okay, now if for the concept of this term solubility limit, you may take the same example of sugar water system or sugar water syrup. Same thing, same type of operation you may do, that is you may continuously add the sugar into the sugar water syrup. After some phase, okay, okay, I will send the lecture. Please try to listen. I will send the lecture along with the note. Then you may hear my voice. Okay, okay, okay. Now, after some point, when the solution is saturated, then obviously the sugar cannot be dissolved in the solution. And this figure, I think you can see this figure. This is the graph of solution, the percentage of solute in a solution of a sugar water mixture or sugar water syrup. Okay, this x-axis representing the what percentage of sugar and water. There are two lines, one is for sugar, one is for water. uh, At the initial stage, weight percentage of sugar is 0 and weight percentage of water is 100. This is not any representation of mass. This is only the percentage, weight percentage of sugar and water. In a solution, at the initial stage, the weight percentage of sugar is 0 and weight percentage of water is 100. After increasing the value of sugar, the weight percentage value of sugar, you may make the solution more concentrated, and at the end point, when the weight percentage of sugar is 100 and weight percentage of water is 0, then obviously this is an idealistic assumption, but that is not possible. But in this point, at this point actually, the sugar percentage, weight percentage is 100 and water weight percentage is 0. But in practical case, the practical scenario is that after 80% weight composition of sugar, that solution cannot take any further sugar um, component in the solution, and in that case 20% of water weight of water may be present, and this is the solubility limit of sugar in a sugar water syrup. And obviously this is dependent on the temperature. In the y-axis, the temperature is represented, and obviously when temperature is increasing, the solubility limit is also increases, and at the temperature of 0 degree Celsius, obviously the solubility limit is 60 percentage of sugar weight and 40 percentage of water weight, and as the temperature increases, solubility limit will also increase. This point of solubility limit is representing the solubility limit of 100 degrees Celsius. Okay. This is the concept of solubility limit, and obviously at a certain temperature the solubility limit of two components or two compounds of a mixture is constant. In this case, in the sugar water system, obviously you may take the 70 degrees Celsius. 70 degrees Celsius, the solubility limit of sugar is sorry 70 degrees Celsius solubility limit of the sugar is almost 60 sorry 70 or 72 percentage maybe, okay, by weight. This is the concept of solubility limit. Now coming to the next part of the concept of phase diagram. The module name is phase diagram. Obviously you have to understand the concept of phase diagram. To understand the phase diagram, first of all you have to understand the concept of phases. Phases is obviously nothing but the two different components or two different compounds which are not in homogeneous condition. That those are called phases. That means when in a sugar syrup solution, when the solubility limit is not reached, obviously that solution is not a multi-phase system, that is a single phase system, and that is one phase. But when the solubility limit of sugar is exceeded, then obviously in that solution there will be two different phases. One is sugar water syrup, and one is solid sugar. In that particular point of time, there will be two different phases. Obviously, the phase is nothing but the homogeneous system or homogeneous material or alloy that is present in one system, and there may be two or more different phases in one specific system. Okay. Obviously you know that this line you single phase system is called homogeneous system. Homogeneous system means obviously there is no uh, different characteristics of the material, and uh, uh, when there is some different phases with different characteristics and properties, obviously that system is called mixture or heterogeneous system. This is the concept of phase. Phase diagram. About phase diagram we will discuss about in the later next class, or maybe after that, but this is the concept of phases. Okay. Now next topic is phase equilibrium. Phase equilibrium is nothing but when the mixture or the system, maybe mixture, maybe system, homogeneous system, maybe not homogeneous system, that is heterogeneous mixture in one system, when the components or compounds are in equilibrium condition, that is no more components or no more compounds may be added to the mixture. Like you may take the same example. I am taking the same example for your easy understand, that is sugar syrup or sugar water syrup. Okay, now in that case the phase equilibrium you may consider at a specific temperature, maybe at 20 degrees Celsius temperature. At 20 degrees Celsius temperature, from the graph 20 degrees Celsius temperature, this point, the solubility limit is almost 65% of weight of sugar and 40% of weight of water. Now, if the solubility limit is 65%, then obviously at 20 degrees Celsius, you will not able to add more than 65% sugar in the solution, and obviously in that case 40% weight of water will be present in the solution. In that particular point of temperature, particular point of time, the system will be in equilibrium condition, that is actually the phase equilibrium. Obviously when you rise the temperature up to maybe 70 degrees Celsius or 80 degrees Celsius or 50 degrees Celsius, in that point of time the equilibrium condition will be temporarily disturbed, and if the solution is attached to the solute, that means the sugar, that means adjacent to the sugar, then obviously in no time the sugar will readily dissolve into the syrup. And if you consider the temperature of 100 degrees Celsius, and 100 degrees Celsius the solubility is 80%, and the sugar will start dissolve into the water, and after some time you will get a saturated sugar syrup solution with 80% weight of sugar in that solution. And at that point of time the sugar syrup solution or sugar syrup system will reach the equilibrium condition. This is actually the concept of phase equilibrium. Okay, now one important thing, that is obviously this subject is not related to this kind of simple sugar syrup solution. This subject is related to obviously alloys and all those things, solid mixture, solid systems. In those cases of solid system or solid mixtures, this metastable condition may happen, that is in sugar syrup system or sugar syrup solution, sugar will dissolve readily in no time or in very less time, but in solid mixture or solid or alloy system, the solid components or compounds are not so much easily dissolve soluble in the mixture. In that case, in those cases, maybe you may get that that equilibrium condition is not reaching after a longer time, and obviously in practical cases those mixtures will not obtain the equilibrium phase equilibrium after a infinite time limit. Okay, that is that type of systems or that types of states are called metastable state or metastable condition. Metastable conditions are nothing but when the phase equilibrium is not achieved after a long amount of time. Okay, this is called metastable state or metastable condition. And this is all about the concept of phase and phase diagram. Not phase diagram, actually phase diagram I have not started yet. This is the concept and definition of phase, components of a system, solubility limits and solutions, and phase equilibrium. And obviously phase equilibrium is nothing but some related with that energy system. When there is some greater energy, that is if you rises the temperature up to 100 or 80 degrees Celsius, obviously you have given extra energy to the solution, and to make the solution in equilibrium condition, obviously that energy will be stabilized by taking more solute into the system. That is actually the thermodynamical concept of phase diagram. Okay. Okay, I'm finishing the today's lesson. Now you may ask if you have any query or confusion. Yes, anyone? Hmm. Yes, anyone want to ask any question? Have any confusion up to this? Uh, I told na, don't write your names and roll numbers like this. I will take the attendance from the Google quiz, not from here. Okay, if you don't have any query or question, I am finishing the class, and right after the class I will send the notes along with the lecture and obviously with the Google quiz. Okay, you have to submit it by today or by tomorrow maybe. From that I will take the attendance. Okay, okay, okay. Thank you all.